Good morning, students. Let us continue the discussion regarding chemical kinetics. Today we are going to discuss about the important concept, that is integrated rate equation. Integrated rate equation. This is the concept we are going to deal in the today's class. Okay, what is integrated rate equation? Already you know the differential rate equation. What is differential rate equation? The instantaneous rate equation is also called as differential rate equation. For the reaction R u raised to product, we can write it as dr divided by dt. This is called as what? Differential rate equation. Differential rate equation. It is also called as instantaneous rate equation. Here we will have a negative sign. Negative sign indicates that it will have the value increase, the decreased value as the time passes. Okay, the concentration of reactant decreases with a change in the time. Okay, here today we are going to study about integrated rate equation. What is integrated rate equation? We have to apply integration for this equation. Why should we apply the integration? Because by applying the integration, we can get a very accurate value for anything which is in a change. ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ, ಯಾವುದೇ ರೀತಿ ಚೇಂಜ್ ಆಗ್ಬೋದು, ಅದು ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ, ನಿಮಗೆ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ ಬೇಕು, ಅದರ ಬಗ್ಗೆ ಚೇಂಜ್ ಆಗೋದ್ರ ಬಗ್ಗೆ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ ಬೇಕು ಅನ್ನೋದಾದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ದ ಇಂಟಿಗ್ರೇಷನ್. Okay, by applying the differentiation means by using the differential rate equation you can get the almost accurate value. But by applying the integration you can not get almost accurate value. You will get the accurate value. For that purpose we need to apply what? We need to apply the integration for the differential rate equation. Okay, let us study about the differential rate equation in the today's class. Okay. First of all, for zero order reaction, what we are going to study now? Integrated rate equation for zero order reaction. Okay, consider a zero order reaction. Consider a zero order reaction in which reactant u raised to product. Okay, rate is given by this rate rate is equal to minus dr divided by dt. That is equal to what? K into rate expression K into molar concentration of R to the power 0. Again, it is zero reaction. It means the rate is independent of the molar concentration of the reactant. That's zero. Okay, because it is zero reaction. Okay, continue the discussion now. Okay, now dr is equal to dr divided by dt is equal to K into 1. Is it? You all know that anything with a rise to the power 0, it will have the value 1. Okay, then this dr is equal to dr is equal to minus K into dt. Minus K into dt. I have taken this negative sign to this side and I have sent the denominator dt to that side. You will have the multiplication with the K. It is what? dr is equal to minus k into dt. Okay, now integrating on both sides means what? You have to apply the integration on both sides of this equation. Okay, on both sides of this equation, what you will have? Integration of dr. Okay, integration of dr is equal to minus k into integration of dt. We have studied about integration. Okay, it is in the form of integration of dx with respect to x. Okay, integration of dx. What you will have? You will have the x value. Okay, then therefore we will have here r. Namaga ಏನು ಸಿಗುತ್ತೆ ಈಗ? r ಅಂತ ಸಿಗುತ್ತೆ ಹಂಗಾರೆ. Here k as it is, we need not to apply the integration for the constant values. If you apply the integration, again you will have the same value. Okay, ನೀನು ಔಟ್ಸೈಡ್ ತಗೊಂಡ್ರೆ ಮಾಡಬಹುದು ನಾನು. ಹೌದಾ? ಇಲ್ಲೇ ಬರುತ್ತೆ ನನಗೆ. It is what? It is also again in the form of integration of dx. In the place of x, we are having dt here, t here. Okay, again we will have k into t. Okay, it is the equation we have got after applying the integration for this equation. Okay, now let this be equation number 1. Let this be equation number 1. At t is equal to 0. At t is equal to 0 means what? At a time 0. And initial level reaction start agilla. At t is equal to 0, molar concentration of R is equal to R0. What is R0? R0 is initial concentration. What it is? It is initial concentration. R0 initial concentration. Beginning you can take 2 moles, 0.5 moles, 0.05 moles, or even 100 moles. R0 is what? Initial concentration. First thing you will time t equal to 0 is that at t is equal to 0, R is equal to what? R0. Okay. Substituting in equation number 1, we have substitute the t value and r value in the equation number 1. Equation number 1 was substitute ಮಾಡಿದ್ದಾರೆ. ಏನು ಸಿಗ್ತದೆ ನಿಮಗೆ? In the place of r, I can write r0. Is it? In the place of r, I can write the r0 is equal to minus, wait. Here in this equation, by applying when you apply the integration, you will have the constant here. Is it? We will have a constant here. That constant is written as I. You integration of c and the then I and the okay. Let this be equation number 1 now. Okay. Here r0 is equal to k into 0 plus I. K into 0 plus I. What will happen? R0 is equal to I. R0 is equal to what? I. Now substituting I value in equation number 1 again. Equation number 1 ಒಳಗೆ ಮತ್ತೆ I value substitute ಮಾಡಿ ಈಗ. Okay, what do you get now? Okay, equation 1 ಒಳಗೆ I value ನ substitute ಮಾಡಾಗ here yes R is equal to minus k into t plus R0. Is it? Okay. Yes. Rearrange the equation now. Rearrange this equation. Kt is equal to negative sign. It has gone now because I have changed the position of it minus kt from right side to left side. Value position. Here we will have r0 minus r. Is it r0 minus r? Then k is equal to what you will have r0 minus r divided by t. What it is? Integrated rate equation for zero order reaction. You have to remember this equation. This indicates that k is equal to r0 minus r divided by t. What is r0? Initial concentration of your reactor. What is r? This is important now. This is important. What is r? Concentration remained at time t. Concentration remained at time t. Time t ಇದ್ದಾಗ r ಎಷ್ಟು ಇತ್ತು ಅನ್ನೋದಂತಂದ್ರೆ ಓಕೆ ಹಂಗಾರೆ ನೋಡಿ ಟೈಮ್ t ಎಷ್ಟು 10 ಸೆಕೆಂಡ್ಸ್ ಆಗೈತಿ ಈಗ ನಿಮ್ಮ ಟೈಮ್ 10 ಸೆಕೆಂಡ್ಸ್ ಆಗೈತಿ 10 ಸೆಕೆಂಡ್ಸ್ ಆದಾಗ ಏನಾಗ್ಬಿಟ್ಟು ನೀನು ಮುಂಚೆ ಏನು ತಗೊಂಡಿದ್ದಿ 2 ಮೋಲ್ ತಗೊಂಡಿದ್ದಿ. What is this 2 mole? This 2 mole is r0. Hence t is equal to 0. Now t is equal to 10 seconds. Just use agate idrolaga 2 moles olaga 0.2 mole have used. 0.2 mole ಏನಾಯ್ತು use agate. It has reacted. What is r now? R is how much? R is how much? This much amount of reactant is used in 10 seconds. 10 seconds bargoda use agutade. Agara t is equal to 0 idaga r0 is 2 mole. Now t is equal to 10 second agate iga 0.2 mole has used. It has consumed. R is 1.8. R is what? 1.8. ಅಷ್ಟು ಉಳಿದೈತಿ ಅದು r 10 ಸೆಕೆಂಡ್ ಬಂದಾಗ ಇಷ್ಟು ಉಳಿದೈತಿ. ಇನ್ನು ಮತ್ತೆ t is equal to 15 seconds ಆಯ್ತು ಅಂತ ಅನ್ಕೋ. ಮತ್ತೆ ಸ್ವಲ್ಪ ಖರ್ಚು ಆಗ್ತದೆ ಈಗ ಜಸ್ಟ್ ಅನ್ಕೊಂಡೆ ಏನು ಮತ್ತೆ 0.2 ಮೋಲ್ 0.1 ಮೋಲ್ ಖರ್ಚಾಯ್ತು ಈಗ 0.1 ಮೋಲ್ ಖರ್ಚಾಯ್ತು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರಬಾರ್ದ. ಈಗ ಎಷ್ಟು ಉಳಿತೈತಿ r is 1.7. R is what? Reactant concentration of the reactant remain at time t. ನೀವು ಟಿ ಎಷ್ಟು ತಗೋತಿ ಅಷ್ಟರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದ. ನೀನು ಟಿ ತಗೊಂಡಾಗ ಅದೆಷ್ಟು ಉಳಿದೈತಿ ಅದು ಟೈಮ್ ಬಂದಾಗ 0 ಆಗತ್ತೆ ಬಂತ 1 ಅವರ್ ತಗೋರಿ 1 ಅವರ್ ಬಂದಾಗ r 0 ಆಗಬಹುದು. ಅದು ಪೂರ್ತಿ ರಿಯಾಕ್ಟ್ ಆಗೋಗ್ಬಿಡುತ್ತೆ ಏನು ಉಳಿದಿಲ್ಲ ಅಲ್ಲಿ. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ವಾಟ್ ಈಸ್ r? Reactant remain at time t. ನೀನು ಟೈಮ್ t ಎಷ್ಟು ತಗೋತಿಯಲ್ಲ ಅವಾಗ ಎಷ್ಟು r ಉಳಿದಕ್ಕೆ ಅನ್ನೋದು ರಿಯಾಕ್ಟೆಂಟ್ ಉಳಿದಕ್ಕೆ ಅನ್ನೋದು ಕ್ವಶನ್ ಓದುವಾಗ ಬಹಳ ಜನ ಇಲ್ಲಿ ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀರಿ. ನೀವು ಬಹಳ ಜನ ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀರಿ. ಓಕೆ ಏನು ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀರಿ ನೀವು r0 ಗೊತ್ತಾಗ್ತದೆ r ಕಂಡುಹಿಡಿದು ಬಹಳ ಕಾಂಪ್ಲಿಕೇಶನ್ ಮಾಡ್ಕೋತೀರಿ. ಯಾಕೆ ನೀವು ಸರಿಯಾಗಿ ನೀವು ಕ್ವಶನ್ ಅನ್ನ ಓದೋದಿಲ್ಲ. ಅದಕ್ಕೆ r ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. ವಾಟ್ ಈಸ್ r? It is the concentration of the reactant remain at t, not reacted. ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗೈತೆ ಅನ್ನೋದು ಅಲ್ಲದು ಎಷ್ಟು ಉಳಿದದ ಅನ್ನೋದು. ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ? ಕ್ಯಾಲ್ಕುಲೇಟ್ ಹೆಂಗೆ ಮಾಡ್ತೀವಿ? ಈಗ ಇನಿಷಿಯಲ್ ಒಳಗ ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗೈತಲ್ಲ ಅಷ್ಟು ಮೈನಸ್ ಮಾಡ. ನಾನು ಅದನ್ನೇ ಮಾಡಿದ್ದೀನಿ. 2 ಮೋಲ್ ಇತ್ತು 0.2 ಮೋಲ್ ಏನು ಇಸ್ ರಿಯಾಕ್ಟೆಡ್. 2 ಒಳಗ 0.2 ಮೈನಸ್ ಮಾಡಿದ್ರೆ 1.86 ಬರುತ್ತೆ. ಇಸ್ ಇಟ್ ಓಕೆ? ನನಗೆ ಇದು ಸಿಗುತ್ತೆ. ಹಂಗಾರೆ ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ನೀನು ಭಾಳ ಜನ ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀವಿ. ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗಿರ್ತಲ್ಲ ಅದನ್ನ ಯಾರು ತಗೋತಾರ ಅಲ್ಲ. ಇಲ್ಲಿ ರಿಯಾಕ್ಟ್ ಆಗಿದೆ ಕೊಟ್ಟಾಗ ಆರ್ ಏನ್ ಆಕ್ಚುಲಿ ಎಷ್ಟು ಉಳಿದೈತಿ, ಹೌ ಮಚ್ ಆಫ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹ್ಯಾಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಸ್ ರಿಮೇನ್ ಅಟ್ ಟೈಮ್ ಟಿ. ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ that one here. Understood or not? Okay. Now here let's have the graph here. The graph and draw ಮಾಡಬೇಕು ಈಗ ನಾವು. ಹೌದಾ? ಗ್ರಾಫ್ ನ ಡ್ರಾ ಮಾಡಿ. ಯಾವುದಕ್ಕೆ ಗ್ರಾಫ್ ಡ್ರಾ ಮಾಡಬೇಕಂದ್ರೆ draw the graph between graph concentration R versus time. Graph draw ಮಾಡಿ. Okay, means by using equation number 1. Okay, equation number 1 is in the form of y is equal to mx plus c. Is it? It is in the form of y equal to mx plus c. What is y equal to mx plus c? It is a straight line equation. It is what? A straight line equation. First piece of considering agar niಮಗೆ straight line ಸಿಗ್ತದೆ ಈಗ graph. ಹೌದಾ? Let us have a look. This is the graph. In the y-axis, take the time. Sorry, in the x-axis take the time, and in the y-axis take the r. Okay, you will have graph like this. You will have the graph like this. Okay, here y is in the y-axis. We have taken the r. We have taken what? R. R changes with the time. Is it? R concentration of reactant changes with the time. How that? And as time increases, concentration of R decreases. Therefore, you will have the slope of this line as negative k. As what? Negative k. You know, equation number 1 k value negative ಐತಿ. Slope ನಿಮಗೆ ಏನು ಸಿಗುತ್ತೆ ಅಂದ್ರೆ negative ಸಿಗುತ್ತೆ. ಯಾಕಂದ್ರೆ k ಐತಿ ನೋಡ್ರಿ. In the place of m we are having k here. That is a negative. Why do you have the negative value? Because r value decreases as the time increases. Okay? Then if you extend this one, if you extend this line, what do you get? You will have R0 value. Again another R0. Initial concentration. Intercept. It is what? Intercept. I value is it? Okay? Intercept. That is what? R0. Andre ನೀವು 2-3 ಕಡೆ ನೀವು ಪಾಯಿಂಟ್ ಅನ್ನು ತಗೊಂಡು ಸ್ಲೋಪ್ ಡ್ರಾ ಮಾಡಿಕೊಂಡು ಆ ಲೈನ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡು. ನಿಮಗೆ ಏನು ಸಿಗುತ್ತೆ? ಇನಿಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಸಿಗ್ತಕ್ಕಂಥದ್ರ. ಇನಿಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಸಿಗ್ತತಿ. ನೀವು ಅಷ್ಟು ಈ ಲೈನ್ ಮುಗಿಪಟ್ಟ ಪಾಯಿಂಟ್ ಹಾಕ್ತಾ ಹೋಗ್ಬೇಕಂತ ಏನಿಲ್ಲ. ಒಂದು ಎರಡು ಕಡೆ ಲೈನ್ ಪಾಯಿಂಟ್ ಹಾಕೋ, ಡ್ರಾ ಮಾಡ್ಕೋ, ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡು. ಯು ವಿಲ್ ಹ್ಯಾವ್ ವಾಟ್? R0 ವ್ಯಾಲ್ಯೂ. Is it? This is about the integrated rate equation for the zero order reaction. Under what? ನಿಮಗೆ ಏನು ಕೇಳ್ತಾರೆ? ಇದು 3 ಮಾರ್ಕ್ಸ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ. You have to derive all the equation and you must draw the graph also. Graph ಕೂಡ ಡ್ರಾ ಮಾಡಬೇಕು ನಾನು. ಹೌದಾ? By using equation number 1. ಹೌದಾ? equation number 1 by ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಆಮೇಲೆ ಇನ್ನೊಂದೇನು ಇಂಪಾರ್ಟೆಂಟ್, ನಿಮಗೆ 1 ಮಾರ್ಕ್ಸ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ. You will be given this graph in the examination. You need to find out the order of the reaction. Order of the reaction find out ಮಾಡಬೇಕು ನಿಮಗೆ. ಅದು ನೋಡ್ರೆ ಗೊತ್ತಾಗ್ತದೆ ನಿಮಗೆ. ಹೌದೋ ನಿಮಗೆ ನೋಡ್ರೆ ಗೊತ್ತಾಗ್ತದೆ. Order of the reaction is zero order. Zero order ಮಾತ್ರ ಹಿಂಗೆ ಬರ್ತದೆ. Understood or not? Okay. This is about integrated rate equation for zero order reaction. Now let's continue the discussion regarding the integrated rate equation. Already we have studied about integrated rate equation for zero order reaction. Now let us study for first order reaction. For first order reaction. Okay. Now let us now consider a first order reaction R given to P. Okay, then rate is represented by rate is equal to minus dr divided by dt is equal to k into concentration of R raised to the power 1. Why? Power is 1. Why exponential value 1? Because we have taken the first order reaction. Okay, first order reaction with the exponential value is 1 in the matter. Is it? Then, if you simplify this equation, what do we have? dr divided by dt is equal to, or dr divided by dt is equal to minus k into r value. Okay, anything with exponential value 1, you will have same value. Okay, yes. Now we are having dr divided by dt is equal to minus k into r. Now exchange this one. dr divided by r is equal to k into dt. Now integrating on both sides. Integrating on both sides. Eradu kade integration apply madre. Here it is integration of dr divided by r. Means you are having the formula in the integration as integration of dx divided by x. Okay, integration of dx divided by x. You will have what? Log x. We will have log x value. Okay, note that. What do we have now? Log. In the place of log in the chemistry we will use ln here. Actually you will have ln r. What you will have? Ln r. How that in our formula integration formula integration of dx divided by x is equal to log x. How that? Other formula is again. Therefore we are having in the place of log x we are having ln r. And the log is in the ln permanently. Again we can convert the ln into the log. Change of method. It is equal to minus k as it is. Okay, integration of dt. What do you have? Into t plus I. Integration constant. I is what? Integration constant. Okay, let this be equation number 1. And equation number 1 I get like that. Okay, now again take the same condition at t is equal to 0, r is equal to what? R naught. What is R naught? Initial concentration of the reactant. Please remember again. Initial concentration of the reactant. Now, substituting in equation number 1. Substituting in equation number 1. We have substitute the value of t and value of r in the equation number 1. Substitute ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? ln r naught is equal to minus k into 0 plus I. Is it? This whole term becomes 0. Ln r naught is equal to I. Agar I value ಸಿಕ್ಕಿದೆ ನಮಗೆ. What do we get now? What do we have got now? I value. Substituting in equation number 1. Substituting value of I in equation number 1. Equation number 1 ಒಳಗೆ value of I ನ substitute ಮಾಡ್ರಿ. ಹೌದಾ? ಏನು ಸಿಗುತ್ತೆ? ln R is equal to minus k into t plus ln R naught. Ln R naught. Is it? Now, Kt is equal to negative sign में था करेंगे. Okay, it has removed now. Kt is equal to ln r naught minus ln r. In which form it is? Log a minus log a ಅಥವಾ log b. ನೀನು ಏನಾದ್ರು ತಗೋಬಹುದು. ಓಕೆ, ಯಾವ ಫಾರ್ಮ್ ಇದೆ? log a minus log b ಅಥವಾ log m minus log b. All the formulae of log logarithm are applicable for the ln also in the same form. ಎಲ್ಲಿ log ಐತೋ ಅಲ್ಲಿ ln ಎಷ್ಟು ತಗೊಂಡೆ ನಾವು? ಹೌದಾ? ಇದು ಯಾವ ಫಾರ್ಮ್ ಆಗೈತಿ? log m minus log n ಫಾರ್ಮ್ ನಾಗ ಏನಾಗರ ಈಗ log m by n ಅಥವಾ log a by b ಬರಿಬೇಕು ನಿಮಗೆ. ಹೌದಾ? now k into t is equal to ln r naught divided by r. Is it? ಹೌದಾ ಇಲ್ಲ ಈಗ? ಓಕೆ, ಯಾಕೆಂದ್ರೆ log a minus log b is equal to log of m by n. log of m by n ಈ ಫಾರ್ಮ್ ಮಾಡಬೇಕು. a by b, a divided by b. okay, ಆ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡೋಣ ಈಗ. ಓಕೆ, ಗೊತ್ತಿರಲಿಲ್ಲ. now I want to, what I need to do now, I want to convert this ln into the log. What should we do now? Multiply log by 2.303. log of 2.303 is equal to ln. ಅಂದ್ರೆ ln ಬೇಸ್ಕೊಂಡು ನಾನು ಏನು ಬರಿಬೇಕಂದ್ರೆ ಈಗ 2.303 into log ಅಥವಾ log into 2.303. now k into t is equal to 2.303 into log of r naught divided by r. Is it? now I want k value now. ನಾನು ಡಿಟರ್ಮೈನ್ ಮಾಡಕ್ಕೆ ಹೋಗಿದ್ದಲ್ಲೇ, ಡಿರೈವ್ ಮಾಡಕ್ಕೆ ಹೋಗಿದ್ದಲ್ಲೇ. what is k now? k is equal to 2.303 divided by t. t ಗೆ ತಗೊಂಡ್ಬಿಟ್ಟೆ, divided by t into log of r naught divided by r. what it is? integrated equation of first order reaction. आगे जरा पढ़ते हैं ना तरीके को integrated equation for zero order reaction. that was k is equal to r naught minus r divided by t. it is k is equal to 2.303 divided by t into log of r naught divided by r. k is rate constant for the first order reaction. it is constant throughout the reaction. t is in time. ನೀವು ಯಾವುದೇ ಟೈಮ್ ಅನ್ನು ತಗೋಬಹುದು. at 5 seconds, at 10 seconds, at 40 seconds, at 1 minute, at 15 minutes, at 15.2 minutes, at 60 minutes, at 1 hour. ನೀವು ಬೇಕಾದ ತಗೋ t, that is. okay, now it is r naught initial concentration. initially ಎಷ್ಟು ತಗೊಂಡಿರ್ತೀವಿ? 0.005 moles ಅಥವಾ 0.05 mole per liter. ನೀನು ಏನೋ ತಗೋಪ್ಪ, ನಿನಗೆ ಬಿಟ್ಟಿದೆ. r is what? r is what? concentration left at time t. ನೀ t ತಗೊಂಡಿದ್ದರೆ ಟೈಮ್ ಎಷ್ಟು 5 seconds, 10 seconds, 1 minute, 1.5 minutes, 15 minutes, 60 minutes, 45 minutes ತಗೊಂಡಾಗ r ಎಷ್ಟು ಉಳಿದೈತಿ? how much has left, not how much has consumed. r is how much has left at time t. please remember this while calculating the answers. whenever questions are given, you will get confused in taking the value of r. value ತಗೊಳ್ಳೋಕೆ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊತೀವಿ. ಅದು ಎಷ್ಟು ಉಳಿದೈತೆ ಅನ್ನೋದು, ಎಷ್ಟು ಖರ್ಚಾಗೈತೆ ಅನ್ನೋದಲ್ಲ. ಕ್ವಶನ್ ಒಳಗೆ ನಿಮಗೆ ಖರ್ಚಾಗೈತೆ ಕೊಟ್ಟಾರೋ ಅಥವಾ ಕೆಲವರು ಇಷ್ಟ ಉಳಿದೈತೆ ಅಂತ ಅವರು ಕೊಟ್ಟಿರ್ತಾರೆ. 30% ಹ್ಯಾಸ್ ರಿಮೇನ್ಡ್ ಅಂತ ಕೊಡ್ತಾನವ. 30% ಹ್ಯಾಸ್ ರಿಮೇನ್ಡ್ ಅಂದ್ರೆ ಏನು? r is 30 ಅಂತ ಅರ್ಥ. ಔಟ್ ಆಫ್ 100 30% ಹ್ಯಾಸ್ ಕನ್ಸ್ಯೂಮ್ಡ್ ಅಂತ ಕೊಟ್ರೆ r is 70. 100 minus r, is it? 100 minus r, 100 minus consumed ಅಂತ ಮಾಡ್ಕೊಳ್ಳೋದು ನೀನು, ಹೌದಿಲ್ಲ? ಅವಾಗ r ಸಿಗ್ತದೆ. ಈಗ ನಿನಗೆ ಕನ್ಸ್ಯೂಮ್ಡ್ ಕೊಟ್ಟಾರೋ, ರಿಯಾಕ್ಟೆಡ್ ಅಂತ ಕೊಟ್ಟಾರೋ, ಅಥವಾ ಹೌ ಮಚ್ ಹ್ಯಾಸ್ ಲೆಫ್ಟ್ ಅಂತ ಕೊಟ್ಟಾರೋ ನೀನು ವಿಚಾರ ಮಾಡಬೇಕು. ಓಕೆ, now let us draw the diagram now. means graph. diagram means graph. Again consider equation number 1. Where it is? Yes. Oh, we didn't mention the equation here. Yes, it is equation number 1. See here. Again equation number 1 is in the form of y is equal to mx. Y is equal to mx form again. Okay. Graph is between. Graph is between ln r versus time. Number r togota ille ln r togota. Ln r is y here. Ln r is y. ಯಾವ ಫಾರ್ಮ್ ಒಳಗೆ ಐತೆ ಅಂದ್ರೆ this is in the form of means ln r is equal to minus k into t plus I. It is in the form of y is equal to mx plus c. Is it? Again we will have the straight line here for the graph. Okay? Here ln r. Okay? Ln r. Here in the x-axis take the t. Again we will have what? Slope. Again you will have slope here. Slope matte bardate agante. Okay? Here k is equal to negative slope. Again negative slope. What is intercept? In next time what? Intercept ಏನು ಕರೆಯಲ್ಲ. What is intercept? Intercept is ln r naught. ಬರೀ r ಅಲ್ಲ. ln r ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ln r ತಗೊಂಡಿರೋದು. Is it? Okay, ಎರಡು ಗ್ರಾಫ್ ಗಳ ವ್ಯತ್ಯಾಸ ನೆನಪಿಟ್ಟುಕೊಳ್ಳ್ರಿ. ಈ ಗ್ರಾಫ್ ನ ಕೊಟ್ಟು 1 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರೆ. ಏನಂತ? ಐಡೆಂಟಿಫೈ ದ ಅಥವಾ ಮೆನ್ಷನ್ ದ ಆರ್ಡರ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್. ಫಸ್ಟ್ ಆರ್ಡರ್ ಅಲ್ಲೇನಿತ್ತು ಇಲ್ಲೇನಿತ್ತು ನೆನಪಿಟ್ಕೋ. ಅದನ್ನ ಕೊಟ್ರೆ 0 ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್. Okay? It is what? The derivation of integrated rate equation for first order reaction. Concept is half-life of a reaction. Half-life of a reaction. Okay? It is represented by T half or T 50%. ಎರಡು ರೀತಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. T half or T 50%. What is the half-life of a reaction? ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಮುಂಚೆ. What is half-life of a reaction? It is the time. Half-life period or half-life of a reaction is a time in which concentration of the reactant is reduced to one half of its initial concentration. It is the time in which concentration of the reactant is reduced to one half of its initial concentration. Means what? How much time will be taken for a reaction to reduce its concentration up to 50%. 50% ರಿಯಾಕ್ಟ್ ಆಗಕ್ಕ ಎಷ್ಟು ಟೈಮ್ ಅನ್ನ ತಗೊಳ್ತದೋ ಅದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. 50% ರಿಯಾಕ್ಷನ್ ಆಗಕ್ಕ ಎಷ್ಟು ಟೈಮ್ ಅನ್ನ ತಗೊಳ್ತದೋ ಅದೇನು ಟಿ ಹಾಫ್ ಆರ್ ಹಾಫ್ ಲೈಫ್ ಆಫ್ ಎ ರಿಯಾಕ್ಷನ್. ಒಂದು ರಿಯಾಕ್ಷನ್ 10 ನಿಮಿಷದೊಳಗೆ ಮುಗಿತೈತಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಅದು ಹಾಫ್ ಲೈಫ್ ಎಷ್ಟು ಆಗ್ತೈತಿ? 5 ನಿಮಿಷ. ಒಂದು ರಿಯಾಕ್ಷನ್ 1 ಅವರ್ ಒಳಗೆ ಮುಗಿತೈತಿ ಅಂತ ಅನ್ಕೋ. ಅದ್ರ ಹಾಫ್ ಲೈಫ್ ಎಷ್ಟು ಆಗ್ತೈತಿ? 30 ಮಿನಿಟ್ಸ್. ಹೌದಿಲ್ಲ? ಅದು 50% ಮುಗಿಯಕ್ಕೆ ಎಷ್ಟು ತಗೋತೈತಿ ಟೈಮ್? 50% ತಗೋತಂಗಾರ ಎಷ್ಟು ಟೈಮ್ ಮುಗಿತೈತೋ ಅದು 50% ತಗೋತಂಗಾರ. ಆ ಟೈಮ್ ಏನಂದ್ರೆ ಹಾಫ್ ಲೈಫ್ ಆಫ್ ಎ ರಿಯಾಕ್ಷನ್. I will repeat once again the statement. Half-life of a reaction is the time in which concentration of the reactant is reduced to one half of its initial concentration. The initial concentration 50% ಆಗಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತದೋ ಆ ಟೈಮ್ ಏನಾಗುತ್ತೆ half-life of a reaction or T half. Okay. Now, expression for half-life of zero order reaction ಅದು half life ಕಂಡುಹಿಡಿದಿದೆ ಏನಂತಂದ್ರೆ ಓಕೆ now integrated rate equation for zero order reaction is given by k is equal to r naught minus r divided by t. Is it? It is the integrated rate equation for zero order reaction. Okay, now at t is equal to t half. T is equal to t half or 50% ಆದರೆ r is equal to what? R is equal to what? R is equal to R naught divided by 2. Is it? 50% consume ಆಗ್ತದೆ. T is equal to T half ಅಂದ್ರೆ ಏನು? ಆ ರಿಯಾಕ್ಷನ್ ನ 50% ಟೈಮ್ 50% ಟೈಮ್ ಒಳಗ R ಏನು ಇರುತ್ತಲ್ಲ ಎಷ್ಟು ಉಳಿಯುತ್ತದೆ? R naught ನ ಅರ್ಧ ಉಳಿಯುತ್ತದೆ. ಹೌದಾ? R naught ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. Initial concentration has reduced to its 50% in 50% time. ಅದು 50% reaction 50%. ಒಂದೊಂದು reaction 50% time ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. ಒಂದು 5 ನಿಮಿಷ ಇರ್ತದೆ, ಒಂದು 10 ನಿಮಿಷ ಇರ್ತದೆ, ಒಂದು ಅವರ್ ಇರ್ತದೆ. 1 hour 50% ಆಯ್ತಂದ್ರೆ ಈ ಮುಂದಿನ ಖರ್ಚಾಗುತ್ತೆ ಏನು ಮತ್ತೆ 1 hour ತಗೋಬಹುದು ಅಥವಾ ಜಾಸ್ತಿನೂ ತಗೋಬಹುದು. ಬಟ್ ಆ ರಿಯಾಕ್ಷನ್ 50% ಆಗಾಗ ಇಲ್ಲಿ R naught ಏನಿರುತ್ತೆ ಅದು 50% ಖರ್ಚಾಗಿರುತ್ತೆ. ಓಕೆ, now let us see equation number 1. Substituting value of t and r in equation number 1, we will have k is equal to r naught minus r naught divided by 2 whole divided by t half. Okay. Here k is equal to what do you have here? What do you have here? Here you will have r naught divided by 2 into t half. 2 into t half. If I exchange k and t half, we will have t half is equal to r naught divided by 2 into k. It is what? Formula or expression to calculate t half of zero order reaction. The expression is indicating that t half is directly proportional to r naught, initial concentration in case of the zero order reaction. It means the zero order reaction, t half of the zero order reaction is depend upon the initial concentration of the reactant. By observing the expression or equation, we can say about this point. Okay, this is about what? The calculation of half-life of a reaction in case of the zero order reaction. Continue. Half-life of a reaction for the first order reaction. Okay, the integrated rate equation is k is equal to 2.303 divided by t into log of r naught divided by r. R naught divided by r. Okay. Now again, t is equal to and t is equal to t half. Again what? R is equal to r naught divided by 2 again, or 1 by 2 into r naught. Okay, substituting. Let this be equation number 1. Substituting in equation number 1, what we will have? We will have k is equal to 2.303 divided by t half divided by T half is equal to log of, look at here, R naught divided by R. R naught divided by R naught divided by 2 again. Divided by 2. Okay? This R naught get cancelled. And here 2 is denominator of the denominator. 2 becomes numerator. Is it? 2 ಏನಾಗ್ಬಿಡ್ತು numerator ಗೊತ್ತಾಗಲ್ಲ ಈಗ. K is equal to 2.303 divided by T half log of 2. Log 2. Okay? Then K is equal to 2.303 divided by T half into 0.3010. What is 0.3010? Log 2 value. ಇವೆರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಏನು ಸಿಗುತ್ತೆ ನಿಮಗೆ? K is equal to 0.693 divided by T half. Divided by T half. And finally, we will have T half is equal to 0.693 divided by 0.693 divided by K. What it is? It is equation for T half for the first order reaction. Here what? T half is direct, not directly proportional. Okay, T half is not directly proportional to initial concentration. It is not directly proportional. It is independent of the initial concentration. T half is what? Not directly proportional to R naught here. Directly proportional illa. Zero reaction directly proportional into R naught ಗೆ. T half ಇದಕ್ಕೆ 0 ಒಳಗೆ ಇತ್ತು. First order ಒಳಗಿಲ್ಲ. ಯಾಕಂದ್ರೆ in the equation we are not having R naught here. It means for the first order reaction, the T half is not depend upon the R naught, not depend upon the R naught. But it is about the half-life of first order reaction. Okay, thank you.